Hello. So I'm living in fear that my carpet repair people are going to show up at the exact same moment that I'm supposed to teach you guys this, because that's just kind of how it works in my world. So I'm making this video to prepare, because if I prepare for it, then it won't happen. So here's a scoop. We are looking at 6-2. And we are talking about properties of radicals and exponents. We actually learned these rules before, but we're going to kind of reapply them now that we know how to manage fraction powers. So it's going to just take up more of your brain cells to be able to apply these rules given fractions. So for example, here you already know, I hope, that when you're multiplying these bases, x to the second, x to the fourth, you're going to go ahead and add the powers. And so we end up with x to the sixth. That is not different in this scenario. It's just more of a hassle because you have to add the powers and you have to think back to your fraction knowledge and say, I need a common denominator. The 1 is already over 4, but here I need to double the bottom, which will double the top. And so I'll end up with x to the 3/4. You can't use a decimal, so you're going to have to kind of manage your way through those fractions. In this scenario, we would go ahead and say inside these are being multiplied by one another with the same base, so that part becomes x to the 9. And then when you have a power raised to a power, like we've got going on right here with the 9 and the 2, those actually multiply. So that rule doesn't change, but again, you have to kind of think about each piece. I also could have distributed this to the powers, making it x to the 10 times x to the 8. And when I combine those, I still would have landed in the same spot. So in the this next example, it's the same process, but now I have to deal with the fractions. Think of this as 2 over 1. So 2 over 1, that power gets multiplied by the power of 2 to become 2 to the second. Here at x, my 2 over 1 is going to multiply by my 3 over 2 power. And so when I put those together, I end up with 3 times 2, which is 6, over 2 times 1, which is 2. So at this stage, I have a 6 over 2 power for that. Here, multiplying these, I'd get 2 over 4. Okay, well, I think we all know that this would become a 3. And this next one is going to become a 1/2. Well, now I have to add those together. So I actually have to think, what is 3 plus 1/2? Well, you can't write it as a mixed number. So that would be 2 times 3 is 6 plus an extra. So when I'm done, 2 squared is 4. And then 3 plus a half, written as an improper fraction, would be x to the 7/2. And then that's how I leave my final answer. You don't use decimals in your power. You don't use mixed numbers. Here, I'm going to be distributing a negative. So keep in mind that negatives do not make anything negative. The answers, they are going to ultimately move our numbers. And so in this problem, I move these into the denominator and they become positive, and then I'm done. That's not new. So this is kind of the old business that we already did. This is the new-ish business, and the reason it's new-ish is it's the exact same rules. It's just that now our powers are harder to manage because they are fractions. So I'm still going to multiply the powers as I bring in a power from outside the parentheses. So negative 1/2 times 8 is going to land me at negative 4. And negative 1 over 2 times 3 over 1 is going to give me y to the negative 3/2. Okay, so when I go to write that, I'm going to have 1 over x to the 4th, y to the positive 3/2 for the exact same reason as I used over here, which is if you have negative powers, those pieces move into the bottom. So what else did we remember? Well, we learned with radicals that you can split these up. So when we had, for example, the square root of 12, we broke it into the square root of 4 times 3 because 4 was a perfect square. 3 got stuck in there. So we're going to be using that same thing, but at a higher power level. And then in the problems that were division, we sometimes split them up and we sometimes left them as is, because we used whatever was more helpful to us. So if I had the square root of 5 over 36, I would probably split that one up because I can see that this is going to get stuck under, but that's going to clean up nicely because it's still true that you cannot have a radical in the denominator. So you're doing whatever it takes to get that out of the bottom. This stuff here is sort of math accuracy stuff. We are not going to worry a ton about that right now because it's sort of in depth and we are in a pandemic. But the gist of it is this. When your index is odd, so you're taking the odd root of something, third root, fifth root, seventh root, and so on, these will simply cancel straight up and you will just get that value because again, you can have a negative under there. So in this case, the fifth root of -3 to the fifth power is -3, totally cancels out and you just get that value. However, when you're dealing with evens, you have to keep in mind that you can't take the even index of a negative value. So this is simply saying give the positive answer. That's why the absolute value signs are there. So in this specific example, you can't just cross these off and get -2 because since this is even, you would be getting the absolute value or positive version of that. And so your answer is going to be 2. So just like in the solving video, you actually have to just take time to look at whether your index is even or odd because that's going to impact like the possible answers you can get. So when you go to do these problems and simplify, you have to be cautious and you want to make sure that your answer is in the same form as the question, meaning if the original problem had radicals like A or C, then your answer should be written as a radical. If your original your original question had fraction powers like B and D, then you would leave your final answers as fraction powers. You can work on it however you want. That's what this is talking about. You may switch forms to simplify. I think for most of us, the radical notation is easier. So you might want to work on it in that format, but then go back and change your answer. It's totally up to you. So here what we're going to do is we're going to use some of these rules we are refreshing our memory on up above. They're not new. We've done them before. So I'm going to separate this into parts. I'm going to break this up and say I'm going to do something with that, and then I'm going to do something with this part. I'm just separating them because my rule up here says I can, so I'm going to do that and make my life easier. So now I can go to my chart. My charts are going to be pretty helpful some of the time. So in this case, the cube root of 64 comes out as a 4. Keeping in mind that when you have fraction powers, we learned this last week, this could be rewritten as power over root, which would reduce to 4y to the second power. Alrighty. Now, my original answer was a radical, but I don't have anything left under the radical, so I just leave it as 4y squared. Okay, so I'm going to leave this in this notation with the powers as a fraction. 27 to the 1/3. Now here, this is going to be 1/3 times 3 over 1, because that's what this is. So I'd actually end up with 3 over 3. And then for the q, I'd be multiplying my 12 over 1 times 1 over 3. So I would get 12 over 3. So this is on my chart because this is asking for the cube root of 27. So that's going to be a 3. Here, 3 over 3 cancels down to p to the first power. And here, 12 over 3 will cancel down or reduce down to be a fourth power. It is okay to get fraction powers. I just didn't happen to get them in that particular problem. Alrighty, so let me think about each of these pieces. You don't necessarily have to write them each separately, but I like to think about each piece separately. So this part right here happens to be on my chart. The fourth root of 16 is a straight up 2. Here, if I think about that, it's going to be m to the power over root power. And then on the bottom, n is going to again be to the power over root index power. 2 is 2. The 4 over 4 power reduces to just being to the first power, and then 8 over 4 reduces to being to the second power. So that is going to be my final answer. When I'm looking at this next problem, I'm not going to forget what I have known since forever, which that is that 14 over 2 is going to give me a 7. Then I'm looking at my x's. Now, how did we do this? We used to do this by subtraction or canceling. So basically on the top, I have 1x, and on the bottom, I have 3/4 of an x. So think of 1x as 4/4, and on the bottom, you have 3/4. So either through subtraction or through thinking about what's the difference between those two? Well, 1/4. Where will it go? Well, it will go where I had more to begin with, which is the top, because on the top I had a whole x, and on the bottom I had 3/4. So that leaves me with 1/4 of an x on the top in my answer. Now I look at my y's. Well, I don't have any other y's to to combine it with, so I get y to the 1/3. And then this z is the only one I have to contend with, but it's to the negative power, so it has to move to the top of my fraction, and therefore becomes a positive power finally. And when I'm done, I just look at it quickly and make sure that I don't have any repeated x or y's or z's, so I know I'm finished because those are all by themselves. All right. So take a little minute to try these and then come back and watch the video and see if you did them correctly. All right, guys. So I don't require you to do this, but if you're struggling at all, it is sometimes just visually easier for your brain to think of each piece separately if you write it out. This ends up being on my chart. 2, 4, 8, 16, 32. So here's the deal though. 64, it's not on my 5th column, it's my 6th column, but I can do this. I can split it into 32 times 2. This is going to come out as a 2. And then later in whatever's going to be stuck under here, I'm going to have a 2 as well. Because when I split it up, 32 times 2, the only one that can come out is the 5th root of 32. Taking a look at this, 8 over 5. Okay, well, what I like to think is, how many groups of 5 can I take out? Just 1. That would leave me with 3 left. How about this? Things are coming out in groups of 5 in order to get out. So I have 14. That's going to be 2 groups of 5, so that's 10, leaving me with 4 stuck under. How about this? I'm taking things out in groups of 5, so that leaves 1 group coming out, no extras inside, and then this is going to be my final answer. All right, here I have 4th root of 48, 4th root of x, and the 4th root of y to the 7. So thinking on it piece by piece, 48 is not in my 4th column of my chart, but 16 is, and 16 times 3 is 48. So this part can come out in front as a 2. This part will stay underneath that 4th root. And in there, I'm going to have a 3 that's on the top of my problem. I also am going to still have that x because this is taking out things in groups of 4, and I only have 1 x, so it's kind of just stuck under there. On the bottom, I have 7 y's, and I'm taking them out in groups of 4. So I'm going to take out 1 group, and I'm putting it under the 2 because it's underneath. It's on the bottom of the fraction. So when I take it out from under the radical, it's still on the bottom. If I take out 1 group of 4, that's going to leave me with 3 more. So when you're finished, it's kind of like math prison. You want to make sure that since this is the gatekeeper, as soon as you have 4 of something, you can leave. There's only 1 x and there's 3 y's, so there's not enough of anything to get out from under that radical to be simplified further. So here, excuse me, 54 is not in my third power column, but 27 is, and 27 times 2 is going to be 54. So this, because of my chart, comes out as a 3, and then cube root, the 2 is going to be stuck under. Now let's tackle the x's. I'm taking things out in groups of 3, and I have 4 of them. So that means one group of 3 can come out, but I'll still have an extra x left over. How about 9? Well, I'm taking things out in groups of 3. So I can take out 3 groups of 3, but then I won't have any left underneath the radical. How about z? Still taking things out in groups of 3. So I can take out 4 groups of 3, which would be 12, leaving me with z to the second power, those last 2 remaining. And again, the gatekeeper on this one is a cube root, so nothing should be to a third power or higher, because then it could have come out. But everything under there is a lower power, so it doesn't have the ability to leave. Looking at this next one, it looks a little tricky, but I'm going to get rid of this part because I know that anything to the 0 power is 1. Then I'm going to distribute. So I'm going to have 32 to the 2/5. X is to the 10 over 1 times 2/5. Y is currently to the 1/3, but it's multiplied by 2/5. So here we learned last week that this would be, because this is root on the bottom, the 5th root of 32 squared. When I go to my chart, the 5th root of 32 is 2. 2 squared. The number part of this is going to end up being a 4. How about the x part? Well, if I do the multiplying of the fractions, it becomes 20 over 5. So in my answer, it will be x to the 4th power. How about the y's? If I multiply the fraction powers, I get y to the 2 over 15. There is nothing I can do with that. It doesn't reduce. And so my final, that's not very clear, my final answer there is 4x to the 4, y to the 2/15. So this is about paying really good attention to detail. And there is a partial answer key posted so that you can be more successful. Always use that partial answer key to help you go through them and make sure that you're confident about what you're doing. Hope that helps. Have a good day, guys.